Okay guys, so we're going to do two things in the video today. First thing is fix the Mesa Boogie dual rectifier that just doesn't work at all. Like at all. Second, we're going to install a MIDI modification that adds MIDI to the channel switching and also makes it so it doesn't pop as you go and click your way through the foot switch. So if any of that sounds interesting, we'll get into it right now. So I guess you never really know what you're gonna get here. Bought this thing for 500 bucks, broken on Reverb, and it's in a little bit worse shape than I thought it was gonna be. For some reason, somebody felt it was necessary to remove everything from the front panel, which I don't really understand that. The tubes were removed for shipping, which I guess is good. And the main board was removed from the chassis. You can see that just because the tube sockets aren't visible there. So we'll see what we get. Okay, now that we got it out of there, we can see all the different knobs and things have just been disconnected from the front panel, presumably so you could go and pop this board out, which even then is still really not that easy to do. So let's have a look and swoop. Dude, what in... So you can see right here is the repair they tried to make on this. Looks like they also tried to repair whatever this is. Ah, geez. Okay, well, we'll see how it goes. Okay, so here you have it, the proverbial smoking gun. This is the low voltage rectifier section, the part that takes the 6.3 volt AC windings and makes them to low voltage DC for the for V1 heater supply and for the foot switch and all that stuff. And as you can see, the board around here is pretty burnt out, along with some traces that are under there. So we'll measure the diodes, see how they're doing. Wouldn't surprise me if they're burnt out as well. And we'll see where to go from there. Okay, so a little bit of bad news with this one. It looks like the transformer 6.3 volt windings are shorted to the chassis. So put a measurement here, get a measurement on the chassis, right there. Right there, come on now. I gotta be this way. There we go. 3 ohms. So that's not so great. Sort of implies that the input transformer has failed. So we'll go ahead and take apart the input transformer. Maybe you can just see where the jacket of this wire has been clipped and is touching the metal housing of the transformer, but it looks like I'll need to get a new input transformer for this thing if I want to get it back to life. So after taking a closer look, it looks like the the input transformer is doing what it's supposed to do, and that they've just arranged it so that way the ground wire here is attached to the center tap of the heater wires there. So what I'm doing here to go and test this transformer is I have a function generator that I guess you can't read, applying 60 hertz, 3.3 volts peak to peak to the input of the transformer, and that is 1.15 volts AC, or 1/100th of 115 volts AC. So I can then go and read off all the voltages and verify that they're correct. So right here, I'm reading 5.1 on the 3.3 volt tap. So, well, here, back up to 6.0. So that would correspond to about 6 volts, which is what you would hope that the heater winding would be. So in the previous clip, I had my 1.15 volt source hooked up to white and black, which that corresponds to the spongy setting on the rectifier, or on the input stage, where it actually runs the whole thing at a reduced voltage. So if you move it from between white and black to white and black with a white stripe, that corresponds to the bold setting, which runs it at full voltage. So when that's the case, I measure the 6.6 volts across the heater winding, which is what you would expect. But again, the main thing I learned from this is that this ground wire is internally connected to a center tap of the heater windings, and I would assume that's to reduce 60 hertz or 120 hertz hum in the preamp for an amplifier that's as high gain as the rectifier. So now, as we're looking at the underside of this board, this pin right there is where the high current came in from the melted signal cable that we found earlier. Comes all the way along here, over to here, burns up this trace, and burns up the low voltage bridge rectifier over here. Then it comes out, goes over here, and then that's where it seems like all the high temperature damage stuff stopped. So sitting below here, these two contacts right there, that's an electrolytic cap, and I measure a short across that cap. So I'm wondering if that cap is shorted out, and that's what caused this whole meltdown that we see. So we'll try replacing that cap and see what we get. Okay, so I removed the cap that was over there and measured it, and it didn't measure short. So next I tried removing everything else that's on the 6.3 volt AC line, and that included the Joule LED up, or not LED, the Joule light up here, which measured very low resistance. So I think that's what was tricking me into thinking that there was a short somewhere. So what I'm going to do now is just rebuild the bridge rectifier, low voltage bridge rectifier section over here. And at that point, I think the thing should just power up. So now here's something a little interesting. Right there, that's the output of the bridge rectifier, the low voltage one, which comes over here, goes to pin 9 of V2. And as you ohm it out, it also goes to pins 4 and 5 of V1. Now that is not what the schematic says. The schematic says that only V1 has a DC supply for its heaters, not V1 and V2. So that's probably, well, I have no idea what that is. It's not what's on the schematic though. So if I had to guess what that is, I'd say they probably found that they needed the extra filtering on V2 as well as V1 to help eliminate some of the 120 hertz, 60 hertz hum that you get that can be injected just by putting AC into the heaters. Okay, so here you can see that we've repaired the traces that go to the low voltage bridge rectifier, and also made a few jumpers to jumper the 6.3 volt AC signal over from where it starts out to the next tube that it has to go to. Doesn't look too bad. Okay, so here's the first time we're going to power it up after putting everything more or less back together. I'm a little nervous about some of these EL34s over here maybe flaming out. So what we're going to do, strategy is to turn up the Variac slowly, and if it looks like it's freaking out, or if the power meter shows that we're drawing way too much power, we'll turn it off. Okay, we're at 40 volts, 26 watts. That should just be the heaters. I can see that the bias switch is set to EL34 mode, which is good. Those clickings that you hear, that's the relay starting to come alive. Okay, so here we are at 115 volts. Looks like it's holding steady at 106 watts. Perfect. So we'll do this again, but with after I measure all the high voltage things. So right now this is just the low voltage section that's powered up. And I don't know if you can see the LEDs changing color. I still need to install the green LED. But it confirms all the foot switching stuff is working. It sounds like all the relays are working. So I think this amp is back. So after turning on the power amp, I noticed the bias LED indicating that it's biased for EL34s, that it would turn off after a little while. So we're going to figure out what that's all about. Okay, so at this point we managed to get the thing working. The final thing that was wrong with it, which I'll show in the next segment, is the grounds on it separated. Which is to say, for all the circuits that are over here, they had one ground, and the power supply ground over here was just not connected to it. In the schematic, it's shown to be connected. It's supposed to be. I wonder if it might be a PCB mistake, the kind of thing that you don't catch when you do a hand-drawn PCB like this, instead of trying to use a modern CAD program that has error checks, so you can see if everything's hooked up or if you have continuity errors. So we'll flip it over and show you the wires I had to add in there. Before we get there, let's go and check it out. It's the clean channel turned all the way up just so we can hear it. You can hear a tiny little pop when you go to channel 2. Again, the EQ is set to just whatever it's set to. Another pop. Pretty cool. Okay, so on the underside of this board, gone and connected this black wire from the ground pin of the solo knob to the ground pin of the big B+ filter cap in the power supply section. And that goes and connects the two grounds that were separated on this board. And that's all you need to get the thing back up and going. So I got it put back together here. Put all the knobs and things back on the front. But when I did that, I noticed the jewel light was sort of coming in and out. And that has to do with this cable that comes over from the power tube board to the main board. You can see that one of the wires there is burnt out on it, and that's for the heater, 6.3 volt heater that that runs the Joule light and also all the preamp tubes. And that connection is just burnt out. It was intermittent. So I've ordered a new cable from Mesa, and while I'm waiting for that to show up, tacked on this green wire just so I can keep testing with the amp in the meantime. So I'm about to start drilling this one out to add the MIDI connector, and since it's a dual rectifier, not a triple rectifier, there's some more space along the top of it. So I'm going to go and put that MIDI connector right there, and the mod PCB is going to sit right in this area over here. Just a better layout. Don't need to permanently damage some of the outside facing features, so it leaves the thing more intact. Here you can see all the nasty stuff that the tape job on the inside caught. Prevent that from flying all over the chassis as you go and drill it out. And here you can see the MIDI connector installed in the chassis from the inside. So here it is. We got the mod PCB in there, and everything's working pretty good. We got switching channels through MIDI, nice and silently. Exactly what you'd hope for. Okay, so we have the pilot hole drilled. We have all the tube holes covered up with painter's tape. We have the tapered drill bit here, and we're going to go and drill out the hole. The MIDI connector is about 0.7 inches in diameter, so we're going to aim for 1 tick less than 3/4 on this, which is this middle line in here. So we'll see how we do. Almost there. I think one more notch. One more notch. Ta-da! Here you can see all the nasty stuff that the tape job on the inside caught. Prevent that from flying all over the chassis as you go and drill it out. So here it is. We got the mod PCB in there, and everything's working pretty good. We got switching channels through MIDI, nice and silently. Exactly what you'd hope for. Okay, so I was able to order a whole bunch of replacement parts from Mesa here. I was able to get these standoffs, the mating part of the standoff that secures it into the chassis, and that was really quick and easy to do. Really happy that Mesa still goes and will sell you parts for their old amplifiers. The one that was a little tricky to get is this replacement ribbon cable here. So it took them like 3 weeks to figure out what it was and build it. And in addition, you can see that the old one that was in there, it's has its connectors on there in the opposite direction. In this one, they're both going the same direction. So it took them a long time to get it to me, and even then they didn't get it 100% right. So yeah, I'd say that if you're ordering parts from Mesa, definitely go with the ones that they just have in stock, not something that they have to custom make like this ribbon cable here. But I mean, to their credit, it's ridiculous that they'll even sell me parts for old amplifiers anyway. So overall, pretty happy with customer service from Mesa. So because the cable they sold me had both the connectors facing the same way, you have to go and flip it around when you go and install it. So this green wire here, this is a probe wire or a debugging wire that I had added to 6.3 volt heater. And you can see that it matches up with pin 1 of this cable. So I just have to make sure that pin 1 of this cable goes to 6.3 volt heater on the mating connector. And there you have it, the finished product. So over here we have the mod PCB installed, connected to all the things that needs to be connected to. The MIDI connector down there, the mute switch connected to the output transformer. Head on over here, that's the effects loop on and off, if you're so inclined. Here's the modded effects loop. Just remove the one wire. Now it's in series instead of parallel. Come all the way over here, and that's for the solo feature. Turn that on and off. Redone all the zip ties to get everything back to where it was. Replaced this burned out connector and cable assembly. And yeah. Oh wait. So then we have diodes, the rectifier diodes that had gotten burned out. They're still in there. They're sitting just fine. Very secure, surprisingly secure, even though the PCB below them is burned out. There you have it. I think we're just going to box it up at this point.